Hello everyone, welcome to MK Academic Solutions. So in this video I am going to explain you chemical equilibrium chapter. So the topics here equilibrium constant expression of some reactions. Okay. So far we have discussed about the what is equilibrium, what are the conditions for the equilibrium, and what are the rate constant, and what is the relation between Kc and Kp, everything I have explained with you. And now in this video equilibrium constant expression for some reactions. Okay. So now first let us see case 1, homogeneous. This is case 1, homogeneous gas equilibrium when N is equal to 0. So here what is homogeneous? Homogeneous means, children, all reactants or products are present in the same phase, and here we are discussing about the gas equilibrium. Means here all the reactants and products are present in the gaseous state, and what is delta N is equal to 0? Delta N is equal to 0 means number of moles of gaseous reactants is equal to number of moles of gaseous products. See here delta N, what is the delta N formula? Number of moles of gaseous products minus number of moles of gaseous reactants. See here, this will become equal to 0. See here, number of moles of gaseous products are 2 minus number of moles of gaseous reactant here 1 and here on total 2. 2 minus 2, that is equal to 0. Okay, now for this we are going to express the Kp and Kc, right, and we are going to derive the relation between Kc and Kp also. Okay, the first one, you take H2 gas plus I2 gas is gives rise to 2HI gas. Initial condition, initial condition we are going to take at initial. Okay, first let us rewrite the equation. H2 gas plus I2 gas is gives rise to 2HI gas. Okay, so initial condition at initial. So at initial condition we are assuming we are going to start with the reactants only. So here what is the H2 concentration? We are going to take A, I2 concentration we are going to take B, and HI concentration we are going to take as the 0, which means we are going to start with the reactants only, but we are not at all taking any products. So now here forward reaction is going to take place to attain the equilibrium. Here forward reaction take place to attain the equilibrium. Okay, so after attaining equilibrium concentrations. What is the equilibrium concentrations? So here concentration of hydrogen is going to decrease, iodine is going to decrease, and concentration of HI is going to increase. Okay, now let us see equilibrium concentrations A minus X and B minus X, and this is the 2X. Okay, so now these are the number of moles of H2 gas and I2 gas at equilibrium and HI gas at equilibrium. Now let us take their concentrations at equilibrium. So equilibrium concentrations. Okay, so this is actually equilibrium number of moles, A moles and B moles and 0 moles. It is A minus X moles, B minus X moles, and 2X moles. Okay, so now concentration, we know what is the concentration formula. Concentration, generally we are going to take the concentration, molarity concentration we will take. Concentration formula, number of moles by volume in liter, moles by volume in liter. Okay, so now let us see the concentration of H2 at equilibrium. What is the concentration of H2 at equilibrium? That is A minus X by V, and concentration of I2. What is the concentration of I2 at equilibrium? That is B minus X by V, and concentration of HI at equilibrium, that is 2X by V. What is the V here? V is the volume of container. Now let us see the Kc expression for this. equilibrium constant Kc expression. So here Kc is equal to, we know what is the Kc formula, concentration of products by concentration of reactants raised to their power stoichiometric coefficients. So here what is the concentration of product, Hi square by concentration of reactant H2 power 1 and I2 power 1. So this is the Kc expression. So here concentration of product raised to their stoichiometric coefficient by concentration of reactants raised to their power stoichiometric coefficients. If more than one reactant is there, means we need to multiply it. More than one product also is there, means we need to multiply them. Okay, this is we know, simple. So now let us substitute the equilibrium concentrations in this expression. So now Kc is equal to what is the concentration of Hi here? We know that is 2x by V whole square by concentration of H2. What is the concentration of H2? That is A minus x by V, and concentration of I2 is B minus x by V. B minus x by V. Okay, this is the Kc expression. So now let us simplify it. Here Kc is equal to, when we simplify this, what will get? 4x square by V square into V by A minus x into V by B minus x. Okay, so now Kc is equal to, so V and V square will get cancelled out. What will get here? 4x square by A minus x into B minus x. Okay, so this is the formula we will get. Okay, right. So now here there is no volume term in Kc expression, which means this is not at all depend on the volume change and also pressure change. Okay, so now this is the Kc expression. Now let us see the Kp expression for the same reaction. Now let us see the Kp expression. So this is the reaction they have given. H2 gas plus I2 gas gives rise to 2Hi gas. H2 gas plus I2 gas gives rise to 2Hi gas. So now initial number of moles we are going to consider A, and initial number of moles of I2 we are going to consider as B. Initial number of moles of Hi we are going to consider as 0. So initial moles. Okay, right. Now at equilibrium, so here only reactants are present, means reactants are going to be converted into product to attain the equilibrium. So now at equilibrium what you will get here? Some of the reactants are going to be consumed, they are going to convert it into as product. So here A minus x and B minus x, here stoichiometric coefficient here and here only one, that's why we are going to take directly as x. But here how much it is going to be formed? Here 2 is stoichiometric coefficient is there, is multiplied with x, 2x. Okay, so now total number of moles. So while calculating the Kp here, we need to calculate the partial pressure. For that purpose, first we need to calculate the total number of moles. Total number of moles at equilibrium. Total number of moles at equilibrium. So what is the total number of moles at equilibrium, children? So here number of moles of H2, number of moles of I2 and number of moles of Hi. Okay, so A plus x, sorry, not A plus x, it is A minus x. What is the number of moles of Hi? A minus x plus B minus X plus 2X. So this is the number of moles of H2, this is the number of moles of I2, and this is the number of moles of HI. Okay, the total number of moles at equilibrium, what will get? A plus B minus X minus 2X plus 2X. So here A plus B minus X plus minus 2X plus 2X will get cancelled out. So the total number of moles A plus B. What is the total number of moles at equilibrium? The total number of moles at equilibrium, that is A plus B. Okay. So this is the total number of moles at equilibrium. Now let us calculate the partial pressures. Why? Because here in the Kp expression we need to take the partial pressures. Okay. So what is the partial pressure? Partial pressure formula, partial pressure is equal to mole fraction into total pressure. According to Dalton's law, partial pressure is equal to mole fraction into total pressure. Okay, what is the, according to Dalton's law, partial pressure is equal to mole fraction into total pressure. So in the same manner we are going to follow here. So this formula you keep in mind. Okay, so this is the, according to Dalton's law, partial pressure is equal to mole fraction into total pressure. So therefore here partial pressure of H2, partial pressure of H2 will become what? Mole fraction of H2, mole fraction of H2 into PT, total pressure. So what is the mole fraction formula? Mole fraction formula we know, that is partial pressure of H2 is equal to mole fraction of H2 means, what is the mole fraction formula? Mole fraction is equal to number of moles of particular substance by total number of moles. So mole fraction. So here that formula also remember, mole fraction is equal to mole fraction is equal to number of moles of a particular substance by total number of moles. Okay, so or else here we will represent. Okay, so here mole fraction. However, we might have learned in the solution chapter. What is the mole fraction formula? Mole fraction is equal to number of moles of a particular substance to total number of moles in a mixture. Number of moles of particular substance, number of moles of particular substance, by total number of moles, by total number of moles. Okay, so now here mole fraction indicated with, we know, X. Mole fraction is indicated with not X, chi. Mole fraction indicated with chi. Okay, right. So now let us calculate the mole fraction of partial pressure of different gases here. So first we take the partial pressure of H2. Partial pressure of H2 is equal to mole fraction into total pressure. What is the mole fraction of H2? What is the mole fraction of H2? Means the number of moles of H2 by total number of moles at equilibrium. So what is the number of moles of H2 at equilibrium? A minus X. And what are the total number of moles? Total number of moles at equilibrium is A plus B and into PT. PT is what? Total pressure. Next, in the same manner, partial pressure of I2. Partial pressure of I2 is equal to what? B minus X. B minus X is the number of moles of I2 at equilibrium and by A plus B is the total number of moles into PT, total pressure. Next, partial pressure of HI. Partial pressure of HI at equilibrium that is number of moles of HI at equilibrium, that is 2x by A plus B into PT, total pressure. Okay, so these are the partial pressures of different substances at equilibrium. So now let us write the Kp. What is the Kp expression here? Kp expression same in the manner of Kc, but instead of molar concentrations, what we are going to take here, we are going to take the partial pressures. Okay, so now partial pressure of product HI whole square by partial pressure of HI whole square, partial pressure of HI whole square, partial pressure of H2 into partial pressure of I2. Okay, so now let us substitute these values. In this equation. We know what is the partial pressure of HI, right children? Partial pressure of HI is what? So now Kp is equal to partial pressure of HI. What is the partial pressure of HI here? 2x by A plus B into Pt. 2x by A plus B into Pt whole square by Kp is equal to, okay, by partial pressure of H2 is what? A minus x by A plus B, A minus x by A plus B into Pt into partial pressure of I2. What is the partial pressure of I2? B minus x by A plus B into Pt. Okay, so this is the Kp expression for this reaction. Okay, this is the Kp expression. So now let us simplify this expression. So therefore Kp is equal to what we will get here? Kp is equal to, so here 4x square by A plus B whole square into Pt square right, Pt square into A plus B by A minus x into Pt into A plus B by A minus x into Pt. Okay, this again we will write. Okay, again. So here Kp is equal to, so somewhat again neatly I will write. Kp is equal to 2x. Kp is equal to this multiplied into the bracket. So what we will get? 4x square by A plus B whole square into Pt square into A plus B by A minus B A plus B not A minus x into 1 by Pt into B A plus B by B minus x into 1 by Pt, like that you will get. So now here Pt square, Pt will get cancel out, A plus B whole square, A plus B will get cancel out. So now Kp is equal to, what is the Kp is equal to here? You will get 4x square by A minus x into B minus x. Okay. So when you observe here Kp expression and Kc expression, when you observe Kp and Kc expression, both are having same like. So here Kc is also is equal to what? 4x square by A minus x into B minus x, and whereas Kp is also is equal to 4x square by A minus x into B minus x. Means here Kp is equal to Kc, we can write Kp equal to Kc. Okay, so this is about what? Homogeneous gas equilibrium when n is equal to 0. Now let us discuss factors which influence on the homogeneous equilibrium where n is equal to 0. So here next effect, so now come here, effect of pressure. So here pressure has no effect when n is equal to 0. When delta n equal to 0, pressure has no effect. Pressure has no effect. Why? Because pressure term only is not present in the Kp expression, and volume also has no effect. Why? Because volume term also is not present in the Kc expression. Okay, right. Next, go to the effect of adding of substance. See here, H2 gas plus I2 gas gives rise to 2HI gas. Effect of adding of substance at equilibrium means this reaction is already equilibrium is established, but what we are doing here after existing of equilibrium, we are going to add the substance, means we are going to add either reactants or products. If we add reactant, if H2 or I2 is added, means reactants are added. This point we can make as generalization. H2 I2 are added means, so in which direction the equilibrium shift means forward direction, and HI is added. HI is what? Product. HI is added. What will happen? The equilibrium shift towards the means backward direction reaction is going to be take place. So this point we can make as the generalization for every type of reaction. Next, effect of temperature. So here H2 gas plus I2 gas gives rise to 2HI. So this is the forward reaction. Okay, this is the forward reaction. So here forward reaction is exothermic, and this one is the backward. So backward reaction. See, forward reaction is exothermic means automatically the backward reaction is what? Endothermic reaction. So here forward reaction is favored by decreasing temperature. Every exothermic reaction, you remember children, it is favored by decreasing the temperature, and backward reaction or endothermic reaction favored by increasing the temperature, which means children here, if you decrease the temperature, forward reaction is going to take place. If you increase the temperature, backward reaction is going to be take place. Next, effect of addition of inert gas. Effect of addition of inert gas also, when delta n is equal to 0, there is no effect. Means equilibrium is not at all going to disturb. Okay, see why it is not at all going to disturb means, when you add at constant pressure, when you add inert gas, what will happen? Volume is going to increase. Volume increases. Even though volume increase also, volume has no effect on the equilibrium constant or Kc. Volume has no effect on the equilibrium constant Kc. So that's why addition of inert gas at constant pressure, there is no effect. At constant volume, there is no effect of addition of inert gas. Means at constant volume, how much inert gas you add also, only pressure increases. That pressure is balanced by the reversible reaction without disturbing equilibrium. Okay, so this is applicable for every reaction, but here we need to observe very carefully whether volume is increased or not. Okay, generally effect of addition of inert gas generally majorly we observe or only we observe at constant pressure only, but we are not going to observe at constant volume. Okay, so this is about the a system is in homogeneous equilibrium affected by the factors when delta n equal to 0, when delta n equal to 0. Now let us see one more thing here, that is next type, case 2. Now we are going to discuss about the case 2, homogeneous reactions, homogeneous gaseous reactions when then n is greater than 0. When n is greater than 0 means n is equal to positive value we should get. So now here see, this is the gaseous equilibrium, homogeneous gas equilibrium. All the reactants or products are present in the gaseous state. So in this type of reactions, delta n is equal to, what is the delta n formula? We know already, number of moles of products minus number of moles of reactants. So here how many number of moles of products are there? 2 moles are there, and 2 minus here how many moles of reactant is there? Only 1. So delta n is equal to plus 1 means delta n is positive or greater than 0. Now let us write the equilibrium constant expression Kc as well as Kp for this reaction. Okay, right. First one, equilibrium constant expression Kc. So here first let us take the reaction PCl5 is gives rise to PCl3 plus Cl2, PCl3 plus Cl2. So initial condition at initial. Now let us assume we are going to start with only the reactant, So what is the number of moles here? We are going to take A, and there is no product, 0 moles of products are present, and at equilibrium, what we are going to observe here, only reactant is present, that's why the reactant is going to be converted into product. Some amount of the reactant is going to reduce. So what is the reduced value? A minus stoichiometric coefficient 1 only is there, that's why A minus x, and some amount of product is going to be formed, means amount of concentration of product is going to increase. So that we are going to consider as x and also x. Okay, right. Why? Because here also stoichiometric coefficients are what? 1 only. Right. Now equilibrium concentrations of PCl5, PCl3 and Cl2 we are going to calculate. PCl3 equilibrium concentrations. Equilibrium concentration means we know already, concentration is nothing but number of moles by volume in liter. So at equilibrium, what is the concentration of PCl5? Sorry, it is not PCl5. So that is A minus x by volume in liter, and equilibrium concentration of PCl3, that is x by V, and equilibrium concentration of Cl2, is what? It is also x by V, right. So now let us write the Kc expression for this. What is the Kc expression for this? Kc is equal to Cl2 and PCl3 by PCl5. Okay, this is the Kc expression. So product, it is the product of concentration of products raised to their power stoichiometric coefficient by product of concentration of reactants raised to their power stoichiometric coefficients. Okay, so this is the Kc expression. Now let us substitute the Kc value, this concentration values. What is the Cl2 concentration? That is x by V, and PCl3 concentration, that is also x by V, by PCl5 concentration A minus x by V. Now let us simplify this. Here Kc is equal to x square by V square into V by A minus x. So now here Kc is equal to, so here v square will get cancelled out and will become x square by a minus x into v, a minus x into v. So now here we can consider equilibrium constant depends on what? Volume. Equilibrium constant depends on what? Volume. Kc and volume, how they are related? Kc and volume, how they are related? So here volume increases, Kc decreases. Okay, right, correct only. Kc and how the volume are related? Volume increases. So later we conclude this. Okay, first you remember this. Okay, so Kc is equal to what? X square by a minus x into v. Okay, right. Now let us express the Kp. Kp for this. So how we are going to write the Kp? Kp. How we are going to write the Kp here? Kp is equal to partial pressure of Cl2 into partial pressure of PCl3 by partial pressure of PCl5, partial pressure of PCl5. Okay, partial pressure of PCl5. So now here partial pressure of PCl5. Okay, so now here see what is the partial pressure of Cl2, partial pressure of PCl3, partial pressure of PCl5. So how we are going to find out the partial pressures? Okay, so partial pressure formula is what? Partial pressure of Cl2. Partial pressure of Cl2 is what? Number of moles of Cl2 by total number of moles, which means again once again we will take the reaction. PCl3, sorry, here PCl5, not PCl3. PCl5 gives rise to PCl3 plus Cl2, PCl3 plus Cl2. So now here initial condition A moles and 0 moles at equilibrium. What we are going to consider? A minus x, x and x. So these are the number of moles at equilibrium. So now here total number of moles at equilibrium, that is A minus x plus x that will become A plus x. Okay, total number of moles, how much you will get? A plus x. Total number of moles we are going to get as A plus x. This is the total number of moles at equilibrium. Now partial pressure formulas already we know, right? What are the partial pressure formulas? Partial pressure is equal to mole fraction into total pressure. Mole fraction formula also we know, that is number of moles of a particular substance to total number of moles. Okay, right. Now let us see the partial pressures. Okay, partial pressure of, so partial pressures, so here total number of moles, total number of moles is equal to how much? A plus x is the total number of moles, and number of moles of PCl3, number of moles of PCl5, that is A minus x, number of moles of PCl3, that is x at equilibrium. So same manner number of moles of Cl2, that is also x. Okay, So now partial pressures we calculate. Partial pressure of PCl3, PCl5 we calculate first. Mole fraction of PCl5. Mole fraction of PCl5 is what? Number of moles of PCl5 by total number of moles into total pressure PT. Next, partial pressure of PCl3. What is the partial pressure of PCl3? Number of moles of PCl3, that is x by A plus x into PT. So next number partial pressure of Cl2, that is x by A plus x into PT. X by A plus x into PT. Okay, right. So these are the partial pressures. Now Kp is equal to partial pressure of Cl2 into partial pressure of PCl3 by partial pressure of PCl5. This is the Kp expression. Okay, this is the Kp expression. So now Kp is equal to, what is the partial pressure of Cl2? X by A plus x, x by A plus x into Pt or P, and partial pressure of PCl3 also x by A plus x into P by partial pressure of PCl5 A minus x by A plus x into P or Pt, total pressure. So therefore Kp is equal to what you will get here? X into x, x square into P square by A plus x whole square into A plus x by A minus x, A plus x by A minus x into 1 by P, into 1 by P you will get. So here P and P square will get cancelled out. Okay, therefore Kp is equal to x square into P by here A plus x square also will get cancelled out. So A plus x into 1 by A minus x. This will get. So here what is the final Kp expression? Here will get, children, Kp is equal to x square into P by A plus x into A minus x, A plus x into A minus x. Okay, right. So this you keep in mind. This is the expression. Now relation between Kp and Kc. What is the relation between Kp and Kc? Here we will get. So here Kp is equal to Kc into RT power n. So therefore Kp is equal to Kc into RT. Here why? Because delta n value 1 we are going to get. And units of Kc and Kp already I taught you how to do. Okay. So these are the things. Next, a system at equilibrium is affected by the following factors. See here, effect of pressure. See here is simply remember, children, no need to go to that equations. You just simply remember pressure increases. Pressure increases. What will happen? Equilibrium shift towards where the less number of moles are present, either reactant side or product side. Pressure increases. Equilibrium shift towards where less number of moles is present, number of moles is present, or vice versa means pressure decreases, equilibrium shift towards the more number of moles. See, for example, in this example only, PCl5 is gives rise to PCl3 plus Cl2. This also you make it as the generalization you do here. Okay, no need to worry about the different cases. You just remember that if pressure is increases, so pressure increases means volume is going to decrease. So to nullify that change, so the volume is going to decrease. That's why equilibrium shift towards where less number of moles is present. So here, which side we are having less number of moles? At reactant side, means backward at if pressure is increases. If pressure decreases, forward if pressure is going to decrease. Okay, so this thing we can conclude by using this equation also here. See here, x and p, these are all the terms you remain constant like that. You just consider x square into p is equal to constant. Consider, so here x is inversely proportional to p. X is inversely proportional to p, means pressure decreases, x increases. Means what is the meaning of x here? The amount of substance is reacted. What is the x here? The amount of substance is reacted. So means pressure decreases, x pressure and x, how they are related, like this also you can remember. Okay, pressure and x, how they are related, like this you remember. Pressure decreases, more amount of reactant is converted into product. Pressure increases, less amount of reactant is converted into product. Okay, now you come here, this, see here, what is the x here? What is the x here? The amount of substance is reacted. What is the x here? I am going to consider amount of substance is going to be reacted. So here, pressure and x, how they are related? Pressure and x, how they are related? Inversely proportional. So for example, low pressure means pressure decrease means x is increases. Pressure decrease means x is going to be increase. Pressure decrease, x is increases. Means here more amount of reactant is converted into product. Means at low pressure what will happen? At low pressure forward reaction is going to be take place. Okay. If pressure increases, at high pressure the amount of the reacted substance is very less, means the equilibrium shift towards the backward direction. Like that also you can remember. Okay, so that is about. Next, effect of temperature. So what is the effect of temperature here? So already I told you, this you make it as the generalization. PCl5 is gives rise to PCl3 plus Cl2. Here this is the forward reaction. The forward reaction is what? Endothermic. Forward reaction is endothermic. Here backward reaction is exothermic reaction. Means exothermic reaction, temperature at high temperature exothermic reaction take place. At low temperature forward reaction is going to be takes place. Low temperature forward reaction, high temperature backward reaction is going to be take place. Next, effect of concentration. These two terms you can take as the generalization I told you. So now here what will happen? What will happen here? Concentration, effect of concentration. See here, PCl5 is gives rise to PCl3 plus Cl2. PCl5 is gives rise to PCl3 plus Cl2. So here amount of reactant is increased. PCl3 concentration is increased. So let us assume equilibrium is established. After establishing of equilibrium, what we are going to do? We are some new PCl5, some amount of reactant we are going to add. So the extra added amount of reactant is converted into product. Or else after establishing of equilibrium, we are going to add some amount of PCl5 or Cl2, which means the backward reaction is going to be take place. Means simply remember, at equilibrium, if concentration of reactant is increased, means extra we are going to add, extra amount of PCl5 we are going to add, means that extra added is again converted into products. So which direction? That is forward. After establishing of equilibrium, we are going to add products. Okay, when we add the products, so the extra amount of products converted into reactant. In which direction? Backward direction. That is, okay, reactant concentration added means reactant added forward, product added backward. So this is the generalization thing. Again, you know to go to the different type of effects. Okay, so now effect of addition of inert gas. So here two conditions we will take. At a constant volume, at a constant volume there is no effect of addition of inert gas. Okay, no effect. So this is, simply remember, at a constant volume there is no effect for any type of reaction. At a constant volume there is no effect of addition of inert gas. Next, at a constant pressure, at a constant pressure, what happens, children? Here volume is going to increase. At constant pressure, what happen? If you add inert gas, volume is going to be increased. So volume increases, what will happen? The equilibrium shift towards the more number of moles. So where we are having more number of moles? At product side we are having more number of moles, means forward direction, or simply you can get this information from Kc also. So here Kc is equal to what is the Kc formula for this? So there I wanted to explain you, but I skipped there. Okay, so here Kc is equal to x square by a minus x into v. Kc is equal to x square by a minus x into v. See here, you make all this constant. K you make constant, a minus x also, a also will get, you make constant. So now here x square by v is equal to constant you make, means x square is directly proportional to volume, means volume is going to increase. Consider volume is going to be increase. Not here. Here x square by a minus x into v. See here, if you consider Kc, a minus x are constant. Okay, so here x square is by v is equal to constant. Therefore x square is directly proportional to volume, means volume is going to increase, means x automatically it is going to be increase. X is okay, volume increases means x is automatically is going to be increase. So if x increases, what is the meaning of x? I told you, children. What is the meaning of x? The amount of reactant is reduced or the amount of product is formed. Okay, so more amount of product is going to be formed or more amount of reactant is going to be reduced. Okay, so in that case, which reaction is going to take place? Forward reaction only take place. Or simply remember, if volume increases, the equilibrium shift towards the more number of moles. So where we are having more number of moles? At product side. So product side the equilibrium is going to shift, means that is a forward reaction. Okay, so the next one, the last one, that is the case 3, homogeneous gas equilibrium, when delta n is less than 0 or n is equal to negative also we can take. Okay, so now here homogeneous gas equilibrium, here example they have given. So here like calculate delta n is equal to 2 minus 3 plus 1, so total 4, that is equal to minus 2. So observe carefully, so it's going to be very important. Okay, so now let us calculate the Kc. First write the equation, N2 gas plus 3H2 gas, N2 gas plus 3H2 gas is gives rise to 2NH3 gas. 2NH3 gas. Okay, this is the reaction. So now at initial condition, let us assume we are going to start with only reactants. Okay, A and B. Okay, next this is the 0. At equilibrium, this is the number of moles, not concentration. What we are going to take this as the number of moles. Next, equilibrium. At equilibrium, so this is A minus x and this is the B minus 3x. See here children, coefficient is there 3, so that's why we need to multiply with the 3. B minus 3x and it is 2x. Okay, clear it is. Now let us see equilibrium concentration of N2. What is the equilibrium concentration of N2? That is A minus x by volume, and equilibrium concentration of H2. Equilibrium concentration of H2, that is equal to B minus 3x. B minus 3x by V, and equilibrium concentration of NH3. Equilibrium concentration of NH3, that is equal to 2x by V. These are the equilibrium concentrations. Okay, now let us write the Kc for this. So now let us write the Kc here. Okay, right. So now what is the Kc here? We will write. How we can write the Kc? Kc is equal to equilibrium concentration of concentration of react products by concentration of reactants raised to their power stoichiometric coefficient. Okay, Kc is equal to NH3 square by N2 and H2 concentration cube. This is the Kc expression. So now Kc is equal to what here you will get? What is the NH3 concentration? That is 2x by V. NH3 concentration is what? 2x by V whole square by N2 concentration is what? What is the N2 concentration? A minus x by V into what is the H2 concentration? B minus 3x by V whole cube. So this is the Kc expression. Okay. So now Kc is equal to, so what we can write here? 4x square by V square. Kc, what we can write here? 4x square by V square into A minus x by V into V by or V cube by, okay, sorry, this is the term wrong. Okay, so here V by A minus x into V cube by B cube minus 27x cube. This you will get. Okay. So now here V square, V cube, totally finally we will get the V square in the numerator. Okay. So now here Kc is equal to, okay, Kc is equal to, what we will get? Kc is equal to 4x square by A minus x, 4x square by 4x square into V square by A minus x into b cube minus 27x cube. b cube minus 27x cube. So now here let us assume a is equal to 1 and b is equal to 3. Okay, this also you can do. So here if a is equal to 1, b is equal to 3 means see kc is equal to, what will get kc is equal to 4x square by 4x square into v square, 4x square into v square by 1 minus x into b cube. b what we are going to consider 3, 27 minus 27x cube. Okay, so now here 27 you make common, so what will get 4x square into v square by, so 27 you make common, so 27 if you make common means what will get here 1 minus x into 1 minus x cube into 27. Okay, so like that, so therefore kc is equal to 4x square into v square by 1 minus x to the power 4. 1 minus x to the power of 4 will get a into a square, like that will get 1 minus x into 1 minus x whole cube means 1 minus x to the power of 4 into 27. This is the kc value. Next to kp. Now let us express the kp for this. Okay, so first write the equation. What is the equation here? N2 gas plus 3H2 gas. Okay, N2 gas plus 3H2 gas is gives rise to 2NH3 gas. Okay, so now here, so what are the things I told you? Just remember initial number of moles A and B, and here it is 0. Equilibrium, at equilibrium what will get? A minus x, b minus 3x, and it is the 2x. Next, total number of moles. Total number of moles. Total number of moles what will get? A minus x plus b minus 3x plus 2x. This is the total number of moles. So here A plus b minus 4x plus 2x. So total a plus b minus 2x. This is the total number of moles. A plus b minus 2x. This is the total number of moles at equilibrium. Next, partial pressure of N2. Partial pressure of N2 is equal to, what will get partial pressure of N2? Partial pressure of N2 is what? Number of moles of N2 at equilibrium. That is what is that? A minus x by a plus b minus 2x into p. P is the total pressure. Next, partial pressure of H2. What is the partial pressure of H2? That is b minus 3x by a plus b minus 2x into p. Okay. Next, partial pressure of NH3. Partial pressure of NH3. What is the partial pressure of NH3? That is equal to 2x by a plus b minus 2x into p. Total pressure. Okay. Right. Now let us see Kp. Kp expression. What is the Kp expression? Partial pressure of NH3. Okay, partial pressure of NH3 square by partial pressure of N2 into partial pressure of H2 cube. Partial pressure of H2 cube. Okay, so now Kp is equal to Kp is equal to, what is the Kp is equal to here? Partial pressure of NH3 square. Partial pressure of NH3 is what? 2x by A plus B minus 2x into P whole square by partial pressure of N2. What is the partial pressure of N2? A minus x. A minus x by A plus B minus 2x. A plus B minus 2x. A plus B A plus B minus 2x into P into partial pressure of H2. What is the partial pressure of H2 here, children? B minus 3x. B minus 3x by A plus B minus 2x. A plus B minus 2x into P. Okay. So, into P, this is whole cube. Whole cube we need to take. Why? Because here cube is there, right? So now let us rewrite Kp is equal to, Kp is equal to what we can write here? So here square you multiplied into the bracket 4x square into 4x square into P square by A plus B minus 2x whole square into, so this you make inversion. If you make inversion means what you will get here? A plus B minus 2x. Okay. A plus B minus 2x by A minus x into 1 by P into A plus B minus 2x whole cube by B minus 3x cube into P cube. Okay, this is the formula here you will get. Now let us see A plus B cube, not square here, cube. Here also cube, sorry, cube you will get. Okay, right. So now A plus B minus 2x whole square, A plus B minus 2x, this cube will get, cube will become square. Now P square, P square you will get here. Okay, right. These are the things we are going to get here. Therefore Kp is equal to, what is the remaining things we are going to write? That is 4x square. Numerator 4x square remained into A plus B minus 2x whole square, A plus B minus 2x, A plus B minus 2x whole square by what? Next, what is the denominator remained? A minus x. A minus x into A minus x into B minus 3x cube, B minus 3x cube, so 3B minus 3x whole cube into P square. This is the remained one. Okay, that is the remained one. Okay, right. So now Kp is equal to what you will get here? Kp is equal to, so now this is the value 4x square I have made any mistakes. Okay, no mistakes. Okay, right. Now let's see here Kp is equal to, what we will get here, 4x square into a plus b minus 2x whole square by, so now here let us assume a is equal to 1, b is equal to 3. It's the same thing we are going to again assume. So a is equal to 1, b is equal to 3 means what you get here, 4. Directly you can, a is equal to 1, b is equal to 3, 4 you will get by 1 minus x into 27 minus 27x cube into p square. You will get like this. Therefore, Kp is equal to 4x square into 4 minus 2x whole square by 1 minus x to the power of 4, 1 minus 1 minus x to the power of 4 into p square into 27. This is the Kp expression. Okay, so this is the Kp expression for this. This is the Kp expression here. Okay, right children. So this is about Kp and Kc expression. Now let us see the Kp and Kc relation. So Kp Kc relation, what we will get Kp Kc relation here. So here Kp is equal to Kc into Rt to the power delta n. So here Kp is equal to Kc into Rt to the power minus 2. This is the Kp and Kc relation. So units, how to derive the units, that also I told you. Okay, no problem. Next, you see the a system is equilibrium is affected by the following factors. Effect of pressure. Okay, what is the effect of pressure? So this thing I told you, generalization here, N2 gas plus 3H2 gas is gives rise to 2NH3. This is the forward pressure increases, forward reaction is going to be take place. Why pressure increases, forward reaction is going to be take place means here pressure increases, equilibrium shift towards the less number of moles, and here it is the backward. When the backward reaction is going to take place, when the backward reaction is going to take place here, it is the backward. When backward reaction is going to take place, when pressure is going to decrease. When pressure is decreased, we know the equilibrium shift towards the less number of moles backward. Okay. Next, effect of pressure, this one. Effect of addition of inert gas, or else, okay, we will see the effect of addition of inert gas. We will see effect of addition of inert gas. What is the effect of addition of inert gas at constant volume? At constant volume, no effect. At constant volume, no effect, but at constant pressure, volume increases. So which side volume increases means, see here, if volume increases, the equilibrium shift towards the more number of moles. Equilibrium shift towards more number of moles, towards more number of moles, towards more number of moles means here backward reaction is going to take place. Here which reaction take place? Backward reaction is going to take place. Next, effect of concentration. This is common general thing I told you. Effect of concentration is what? See here, N2 plus 3H2 is gives rise to 2NH3. So in this case, what I told you children, if So now let us assume equilibrium is already established, but here what we are doing, after establishing of equilibrium, if we add reactant, forward reaction is going to take place. If we add product, backward reaction is going to take place. Forward adding reactant, and this is the backward adding product. Next, effect of temperature. N2 plus 3H2 is gives rise to 2NH3. So here it is the exothermic reaction, it is endothermic reaction. Exothermic reaction, at temperature decreases, forward reaction is going to take place, and endothermic reaction, temperature increases, backward reaction is going to take place. Means low temperature forward, high temperature backward. Okay, this is the conclusion about the different states of equilibrium reactions. Okay, so now these all things we can discuss by using this table. Okay, what is this table? I will explain in the next video, but simply you can understand. Pressure, when delta N is equal to 0, there is no effect of pressure, there is no effect of volume, and there is no effect of addition of inert gas. Next, when delta N equal to 0, pressure increases, backward reaction is going to take place. Pressure decreases, forward reaction is going to be take place. These are the things I have discussed. Okay, so now let us conclude this lecture. So thank you for watching.